Next speaker is Raineri, who's going to speak about an invasive crab.
Okay, good afternoon to everybody. I'm going to show you my work about the decapod crabs, Percnon gibbesi in Raineri Island in the center of the Mediterranean Sea. This crab is a flat crab of the family of Plagusids, and it comes from Brazil, from the southern western of the Atlantic Ocean, and now spread, as you can see in green, now spread almost in every circumtropical and subtropical regions, even in the Mediterranean Sea. But in the Mediterranean Sea, it is an invasive species. It is found for the first time in 1999 from Raineri, and secondary spreading very fast around all the coastal of the Mediterranean Sea. The only place you cannot find it is the Adriatic coast, the Adriatic Sea. This is a successful invader, and probably for his high reproductive potential, or because it has a few rare predators like Serranus species, Epinethelus species, and Octopus species, or because he can live in a characteristic habitat difficult to exploit by other species, like boulders covered by coralline algae, especially the algae of Amphiroa corallina imictata species, or because it has a long-lasting larval stadium. The aim of my work was to make a detailed study on the condition of this crab population in Lenosa Island. I checked the distribution, the population density, the reproductive potential, counting the egg production, the diurnal activity rhythms, and relationships between some parameters of biometry and biomass. For the distribution in the island, I make scuba diving and snorkeling transects, and I survey all the coastline infralittoral fringe from 0 to 4 meters depth, and then I made a georeferenced map with discrete qualitative values from very abundant to low abundant, and as you can see, the crab is present in the whole coastal littoral. The triangle, the rules, and the round and the pentagon show the points where I found this crab deeper than 4 meters depth. Especially Manorazza was found at 10.7 meters depth, the highest deep in the, sorry for my English, the highest deep in the Mediterranean. For the population density, I've made some basal census, positioning a washer metric under the rocky bottom from 0 to 2 meters depth and per 5 meter long, and creating a surface area, vertically surface area on the rocky bottom. And I made 5 minutes count on the rocky bottom. I've made 140 dives into here in 7 sampling points around the island, and I calculated the mean values of the density per 10 meters squared. This is the sampling point, and this graph shows you on the x-axis the sampling point from 7.1 from 7, and on the y-point the individuals per 10 meters squared. And testing this data with the two-way ANOVA showed that there's no difference amongst the 2009 data and the 2010 data, but there's a significant difference between the sites. For the reproductive potential, I've made a count of total eggs of 21 females under stereo microscope. The carpet length of these females was about between 1 and 3 centimeters length. This is an example of the egg evolution from homogeneous aspect to hyoid aspect. The mean diameter of the eggs was about 0.37 millimeters. This graph shows you the size classes on the x-axis of the carpet's length of the crab, and on the y-axis the number of the total eggs. There was only 18 out of 21 ovigerous female, no ovigerous female under 1.5 centimeters of carpet's length, and the average reproductive potential is assessed by 3,622 eggs per female, with a maximum of number of 7,850 eggs per female, in a female of 2.8 centimeters of carpet's length. For the diurnal activity rhythms, I studied one site, Casolto site, S7 site, and I've marked two typology of dance, 5 Tradices dance and 5 under boulders dance, and I have checked the number of the crabs' presence in dance in 3 sampling periods, morning, afternoon, and evening, and I have made 2 crabs counts per den in each sampling period, waiting 10 minutes before doing the second count, and in total I've made 959 dives. These graphs show you the delta crabs into den between the first and the second counts of each sampling point, and on the y-axis the frequency of occurrence of these crabs. The data was tested by the Percnon, and I checked 4 factors: the date, the period, the den type, and the year, 2009 and 2010. And the output shows that there is no significant difference in crabs count among this factor, but that the crabs hardly moves from their dens. For the biometry and biomass, I collected 40 specimens in 2010, and I measured 14 different parameters of the species. I have measured also the wet weight, dry weight, and hash-free dye weight. And I'm going fast here because I don't want to be boring. These are the sound. This is explaining of the sound length. First lateral spine, the Kira length, the terson width, the terson length. And especially I take the palm length and the pilus groove length because the only good index to assess the difference between Percnon planissimum and Percnon gibbesi, that was 2 species very similar, is the relationships between these 2 lengths. And this is Percnon gibbesi because, the values are assessed between 2 and 4. I found that Percnon gibbesi has 60% of water content, 21% of hashes content, and 20% of organic content, and so it's high in hashes content. And the best fit between morphological variables is with the carpet length and dry weight. This is the graphs of the relationships. In conclusion, I can say that the population density of Linosa Island of Percnon gibbesi is well acclimated, established and stable. Probably it is now in the 3rd step of this Bezius curve, and when it was found in 1999, it was on the 1st or the 2nd stage. And it has an homogeneous distribution along the island on the upper littoral fringe, showing the highest density on the southern part of the island. And I recorded in this work the highest density in the sea, in the Mediterranean Sea. And it has this species have a remarkable reproductive potential, and it is very high in dense fidelity, probably to preventing depredation or to enhancing the survival to improve the colonization success. Thanks for your attention.